गुड इवनिंग क्लास। सो आज का हमारा टॉपिक है वेक्टर्स। सो टुडे वी आर गोइंग टू कवर वेक्टर्स. फर्स्ट ऑफ ऑल वी आर कवरिंग सम single choice questions and then we will cover some multiple choice questions. Now moving to the next first question. Our first question is, if we are having a, b, c are the three vectors and the scalar triple product of them is 4. So basically what is the meaning of scalar triple product is, if we have written vector A, vector B, vector C, then it means A dot B cross C. So we are given the scalar triple product of ABC equals to 4 and we need to find the scalar triple product for A cross B, B cross C, C cross A. Now in place of what we can do here is we can write x, y and z here, so it would be easy to understand. In place of x we are having a cross b, so that will be a cross b dot product with y is b cross c cross c cross a. Okay, now let's say this is some vector, compare it with y, so we are having here y cross c cross a and a cross b outside. Now if you will see here, then this is called vector triple product, or this was a scalar triple product and this is a vector triple product. So what is the formula for vector triple product is, if you are having three vectors, let's say m cross a cross b, then it is equals to m dot b vector a minus m dot a vector b. So here if we are comparing it, we will be having a cross b dot y dot a vector c minus y dot c vector a. Now see, if you will multiply this and with this, so we will be getting y dot a will be a scalar value because it is a scalar quantity and we are having the vector c separately. So that will be y dot a separately and we will be having a cross b dot c, and here minus y dot c, and it will be a cross b cross a. Okay, this quantity we are already having. So from that, and this, if we are doing the cross product and two vectors are same, so from we can see here that in place of y we are having m here. So with this and m already we are having, it is equals to b cross c. So this m dot a will be b cross c dot a. So that will be also a scalar triple product abc. But in this place, when we are having m dot c, So this will be B cross C dot C, and this value will be 0, because in a scalar triple product, if we are having the two vectors which are same, then its scalar triple product is 0. So this quantity is 0 and we are left with only this quantity. So that will be m dot a being a scalar value and a cross b dot c. So this is also a scalar triple product ABC, and this is also a scalar triple product ABC. So we are getting a scalar triple product ABC whole square, and its value was given to be 4, so it will be 4 square, that is 16. So our answer is A. What two concepts we have applied here is, first concept is of scalar triple product and the other concept is of vector triple product. For scalar triple product, if we are having right A, B, C, so that represents A dot B cross C, or you can write it as A cross B dot C. And for vector triple product, A cross B cross C, if you are having, then it is called vector triple product, and it is equals to A dot C vector B minus A dot B vector C. So these are the two concepts we have applied. Moving to the next question. We are given ABC as a vector such that A plus B plus C is 0 and mod A is 7, mod B is 5, mod C is 3. Then we have to find the angle between vector B and vector C. So what we can do here is, we can write B plus C will be equals to negative of A. So B plus C dot product with B plus C will be equals to negative of A dot product with negative of A. So this will be B plus C dot product of B plus C equals to A dot A. If we are having two vectors and we are doing the vector scalar product, say x dot x, so that will be mod x into cos 0 degree, because the angle between the two equal vectors will be 0, and cos 0 degree we know that it is equals to 1, so this will be equals to mod x square. Or we can write it simply as x square. Here x is representing mod of x, so here it will be b dot b, that will be mod b square, plus b dot c plus c dot b plus c dot c, that will be mod c square, and a dot a will be equals to mod a square. We are given the values, substituting these values, and for scalar triple product it is commutative in nature, that is b dot c will be equals to c dot b. So we can see that 2 times of b dot c is equals to a square minus b square minus c square. So putting the values, we will be getting 2, and b dot c will be equals to mod b into mod c into cos theta. So we are having cos theta equals to a square minus b square minus c square upon 2bc. Substituting the values, we will get cos theta equals to a square will be 49, b square will be 25, c square will be 9. So that will be 15 divided by 2 into 5 into 3, again 15. So that will be 1 by 2. And cos theta is 1 by 2 and theta equals to 60 degrees. So our answer is A, 60 degrees. Okay. So moving to the next question. In this question, we are given mod A is 5, mod B is 4, mod C is 3. We have to find the value of A dot B plus B dot C plus C dot A. So we are given A plus B plus C equals to 0. So what we are going to do is we are going to find the dot product of A plus B plus C with itself. Since A plus B plus C is 0, so dot product of A plus B plus C with itself will be also equals to 0. So we'll be getting A dot A, that is mod A square, plus mod B square, plus mod C square, plus 2 times of A dot B plus B dot C plus C dot A, and that will be equals to 0. So 2 times of A dot B plus B dot C plus C dot A is equals to negative of mod A square plus mod B square plus mod C square. We are having mod A, mod B and mod C. So their squares will be 25, 16 and 9. So that will be minus 50, and this 2 will be in the denominator, so that will be minus 25. But this is the value of A dot B plus B dot C plus C dot A. We need to find the value of mod A dot B plus B dot C plus C dot A. So that will be the positive value, that is 25. So our answer will be A. Now moving to the next question. We are given if the vectors C, A and B are such that ACB forms a right-handed system, then C is. If we say that the system is particularly like X, Y, Z axis forms the right-handed system, that is I cap, J cap and K cap. So we draw it like I cap, J cap, K cap. So on multiplying, that is I cross J gives us K. Similarly, if we are given A, C and B are forming the right-handed system, that is A, C, B. It is like this. So A cross C will give us B, C cross B will give us A, and B cross A will give us C. See, in cyclic form we multiply. A cross C will give you B, C cross B will give you A, B cross A will give you C. So we have to find C. So C is equals to cross product of B and A. And we know how to find the cross product using the determinant. So B, first write I cap, J cap, K cap, and the coefficients of B are X, Y, Z. Oh, sorry. The coefficient of B are 0, 1, 0, and coefficient of A are X, Y, and Z. So this will be I cap Z minus 0, J cap 0 into 0, that will be 0, so no need of writing it, plus K cap 0 minus X. So our vector will be Z I cap minus X K cap. Here this is just J cap. Okay. So our answer will be option number A. Now moving to the next question. In this question we are given A cross B equals to B cross C equals to C cross A, and we need to find the value of A plus B plus C. So let's say on adding vector A with vector B and vector C, we will get a new vector. Let's say its name is R. So vector R equals to A plus B plus C. Let's cross multiply both sides with A. So we will get R cross A equals to A cross A plus B cross A plus C cross A. See, if you are multiplying, either multiply it on the right hand side or on the left hand side. So we have multiplied it on the right hand side. So A cross A will be 0. So R cross A will be, this is 0. B cross A, we can write B cross A as minus of A cross B plus C cross A. Why we have changed it? Because we are having A cross B equals to C cross A. So A cross B and C cross A are equal. So we are having the negative sign here. So these two will be cancelled out and R cross A will be equals to 0. Similarly, you will see when you will do the cross product with B. So R cross B, that will be A cross B, and B cross B will be 0 and C cross B. We can write C cross B as minus of B cross C, and we are having A cross B. Here we are having this A cross B equals to B cross C, that is A cross B, we write B cross C minus B cross C, so these two will be cancelled out and it will be 0. So similarly we can see that R cross C will be also equals to 0. Now this is possible only when R is equals to 0 or A, B, C all are 0. So obviously it satisfies both the condition that A plus B plus C should be 0. So it will be a 0 vector. So our answer is C. Moving to the next question. We are given U, V and W are three non-coplanar vectors, then this value will be. See here, if we will see, then this is some vector, let's say A. This is some vector, let's say B, and this is some vector C. So we are having it in the form of A dot B cross C. So it is just the scalar triple product of A, B, C. And C. If you are having the three vectors in the form of I cap, j cap, and k cap, then the scalar triple product can be written in the form of determinant value. So we can use the properties of determinant in here. Okay. So we are having U plus V minus W dot U minus V cross V minus W. It can be written as U plus V minus W, U minus V, and V minus W. So what were the basic properties of determinants? We can write the row operations, column operation, that is two rows can be subtracted, that is we can write in an R1, that is R1 minus R2, and this is not going to change the value of the determinant. So similarly you can subtract it. So we are doing what we are having, we are subtracting vector A by vector C. So on doing that we will be left with only U. Here you will be left with this and V minus W. Now what we can do here is you can use the basic logic again and you can subtract these two. So you are having, what we are doing is I am writing A, B, C for the first vector, second vector and third vector. For the first vector I have applied this operation A minus C. And that will be similar to the row operations. Okay. And for this we can write it like b minus a. So u will be in its place and you will be left with minus v and v minus w. And for c we can see on c plus b, v and minus v will be getting cancelled out, so we will be having a scalar triple product u minus v and minus w, and taking minus sign common from both the rows, so that will be cancelled out and you will be left with u v w. So we will be having the option p here. This is actually cross product. Okay, so this is equivalent to u dot v cross w. Okay, so what we have done here is we have changed it like we are doing a determinant problem. Because if you are having these vector a as x1 I cap plus y1 j cap plus z1 k cap, vector b as x2 I cap plus y2 j cap plus z2 k cap, and vector c as x3 I cap plus y3 j cap plus z3 k cap, then the scalar triple product of a b c is equals to determinant value x1 y1 z1 x2 y2 z2 x3 y3 z3. Okay, moving to the next question. Now we are given that the particle is acted upon by the constant forces. We are given the two forces in here and it is displaced from this point to this point and the total work done. This is a very simple question. You have to just find the resultant force, that is by adding these two forces, and you have to find the displacement, that is by subtracting the final position vector minus initial position vectors. So the force will be 7 I cap plus 2 j cap minus 4 k cap, and displacement r will be 4 I cap minus 2 j cap, oh sorry, plus 2 j cap minus 2 k cap, and work done equals to f dot r, or you can say r dot f because it is commutative, so it is same. So we will get work done equals to 7 into 4 plus 2 into 2 minus 4 into 2. Okay, sorry, that was minus of minus, that is plus 4 into 2. So the value will be 28 plus 4 plus 8, that is 40 units. So our answer, correct answer is option C. Moving to the next question. We are given A, B, C be the three non-zero vectors such that no two of these are collinear. If the vector A plus 2B is collinear with C and B plus 3C is collinear with A, then we need to find the value of A plus 2B plus 6C. See, A plus 2B is collinear with T, so A plus 2B will be equals to sum lambda times of C, and B plus 3C will be equals to sum, we are already having lambda here, so we can take T1 T2, T1 times of C, and this is something T2 times of C, T2 times of A. Now We can eliminate b from here. So we can find the value of b will be T2a minus 3c and put this value. So a plus 2 times of T2a minus 3c is T1c. So we will be getting 1 plus 2T2a is equals to 6 plus T1c. Now it is also given that these vectors are non-zero as well as these two vectors are not collinear. So A and C will not have any linear relationship. That is, the coefficient of A and the coefficient of C must be zero. If they are not zero, then there will be a linear relationship between the A vector A and vector C, and which is possible only when the two vectors are collinear. Here it is given that the two vectors are not collinear. So 1 plus 2T2 should be equals to 0, that is T2 should be equals to minus 1 by 2, and 6 plus T1 equals to 0, so T1 will be equals to minus 6. Now we need to find the value of A plus 2B plus 6C. So putting this value in here, T1 minus 6, we will be getting A plus 2B equals to minus 6C, that is A plus 2B plus 6C equals to 0. So our correct answer will be option D. Now moving to the next question, we are given UV and W be such that mod U is 1, mod V is 2, and mod of W is 3. If the projection V along U is equals to that of W along U, and V and W are perpendicular to each other, then we need to find the value of mod of U minus V plus W. So what is the basic formula for projection? So if we are having the projection of vector A on B or along B, so it will be A dot B. See, it is like this. If we are having a vector A in here and vector B in here, then the projection is actually the magnitude of the component along this axis. So it is A cos theta. To find A cos theta, we are having A dot B is mod A mod B cos theta. So it will be A dot B upon mod of B, that will be A cos theta. So A cos theta is our projection along vector B, and this is the projection of vector A along vector B. So basically what we are having here is A dot B upon B. So this is the general formula. It is given that is the projection of V along U. So projection of V along U will be V dot U upon mod of U, and is equals to W along U. So projection of W along U will be W dot U upon U. It is also given that these two are equal. So V dot U is equals to W dot U. Mod U will get cancelled out. So we are having this, and it is also given that V and W are perpendicular to each other. So since these two vectors are perpendicular, so their dot product will be 0. Now if you have to find the magnitude of any such vectors, we are having the combination U minus V plus W, and we need to find its magnitude. So what we are having, the basic logic is mod x square is equals to x dot x. So we are having its square will be equals to U minus V plus W dot product U minus V plus W. So this will give us U dot U mod U square minus v dot minus v mod v square, w dot w, that is mod w square. Then u and v with negative sign, this with negative sign to 2 times, and u and w and u 2 times, v and w and minus w and minus v, so that will be 2 times equals to 14. Now here u dot v and u dot w are equal, so these two will get cancelled out and this is given to be 0. So we will be having this quantity, and mod u, mod v and mod w are given. So substituting their values, we will get this value as 14. So mod of u minus v plus w will be equals to root of 14. Moving to the next question. Let A, B, C be the non-zero vectors such that A cross B cross C equals to one third of B mod of C and mod of A. Skip this question. There might be some printing mistake in this, because the cross product will give you a vector quantity and not a scalar quantity, and here we are having all the scalar quantities. Going to the next question. The next question is, we are given the three forces P, Q and R. These three are acting along IA, IB and IC, where I is the in center of triangle ABC and are in equilibrium. Then PQ, vector P, vector Q, vector R, or force PQRS. See, if we are having, by Lami's theorem, we know that if this is the vector P, vector Q, and vector R, these three forces are acting, and this is the in center. In center is the center of the circle inscribing the triangle. So if we are having this as the angle B, then this will be the angle 90 degree plus B by 2. So if we are having this angle B, this will be 90 plus B by 2. And from Lami's theorem, if we are having the three vectors or three forces F1, F2, F3, such that this angle is alpha, this is beta, and this is gamma, then it is F1 upon sine alpha equals to F2 upon sine beta equals to F3 upon sine gamma. So we are having the angle. For A it is 90 degree plus A by 2. For B it will be 90 degree plus B by 2, and for C it is 90 degree plus C by 2. So sine 90 plus A by 2 will be cos A by 2, cos B by 2, and cos C by 2. So our answer is option number A. Now let's start with some multiple choice questions. So our first question is, if the vectors This is the first vector, the second and the third vectors are coplanar, then we need to find the value of x. We know that if we are having the vectors a, b, c coplanar, then the scalar triple product will be equal to 0. And we have seen that the scalar triple product, if we are given the vectors in the form of the components along x-axis, y-axis, z-axis, that is I cap, j cap and k cap, then this can be represented in the determinant form. So we will be having a determinant x, x plus 1, x plus 2, here it will be x plus 3, x plus 4, x plus 5, x plus 6, x plus 7, x plus 8. And since they are coplanar, so this value will be equals to 0. So what we have to do here is we have to solve the determinant value. What we can do is put this operation in C2, that is C2 minus C1. So you will get x, x plus 3, x plus 6, 1, 1, 1, x plus 2, x plus 5, x plus 8 equals to 0. And now put the operation R2, R2 minus R1, and the operation R3, that is R3 minus R1. So the determinant value will be x1, x plus 2. This will be 3, 0, 3. And this will be 6, 0, 6. And on solving along this, so we will be getting 3 into 6. We are opening this determinant, or we can see that if you are taking 2 common, then this will be 303, and these two rows are same, so determinant value will be 0 irrespective of the value of x. So for this, x belongs to any real number, so our options are, all the options are correct, a, b, c and d. Now moving to the next question. The side of the parallelogram are 2 I cap plus 4 j cap minus 5 k cap and I cap plus 2 j cap plus 3 k cap. We need to find the unit vector parallel to one of the diagonal. So if we are having the two sides of parallelogram, let's say this is A and this is B, then the one diagonal is given by vector A plus B. This will be the vector, and the other, from triangle law we can see that A plus this vector will be equals to B, so this will be given by B minus A. So let's find the first diagonal. So it will be on A plus B, A plus B, it will be 3 I cap plus 6 j cap minus 2 k cap. And the other will be on subtracting, that is B minus A, that will be I cap, that will be minus I cap minus 2 j cap and plus 8 k cap. So this is giving us this option. Okay, you need to find the unit vector, so you have to divide it by the magnitude value. And the first one, 3 plus 6 minus 2, I feel this is some misprinting in here. Otherwise, this will have given us option B, or no other option is matching. So we can say that this is the only matching option. Okay, we are having some misprinting in there. So it was showing as option A also, but okay. Moving to the next question, we are given a vector A has the components 2p and 1 with respect to the rectangular Cartesian system. This system is rotated through a certain angle about the origin in the counterclockwise sense. If with respect to the new system A has component p plus 1 and 1, then p is equals to. See, if we are having a vector A making some angle theta 1, and if you have rotated this vector by some angle, let's say theta, and it is now making angle theta 2, then in both the cases we can see that the two vectors have the different directions, but the magnitude of A will be equals to magnitude of B because this vector is only getting rotated. Okay, so initially the components were 2p and 1. So the magnitude of A we can say that was equals to 2p square plus 1 square. And then when we have rotated this, let's say the new vector is B. So mod of V will be equals to p plus 1 whole square plus 1 square. So mod A will be equals to mod of P. So we will be having 4p square plus 1 is equals to p square plus 1 plus 2p plus 1. So that will be 3p square minus 2p minus 1 equals to 0. So we'll be getting 3p square minus 3p plus p minus 1 equals to 0. So p will be equals to 1 or p will be equals to minus 1 by 3. So the two correct options are minus 1 by 3 and 1, that is option number B and C. Moving to the next question. We are given the points are collinear. See, if we are having the 3 points A, B and C as collinear, then vector AB will be parallel to vector BC. So we can find the point is I cap plus j cap, the other point is I cap minus j cap, and the third point is pi cap plus qj cap minus rk cap. So finding vector AB, that is position vector of P minus position vector of A, so that is I cap minus j cap minus I cap plus j cap. So we would be getting minus of 2 times of j cap, and for vector BC that will be position vector of C minus position vector of B. So position vector of C is pi cap plus qj cap minus rk cap minus, for B it is I cap minus j cap, so that will be p minus 1 I cap plus q plus 1 j cap and minus rk cap. See, if these two vectors are parallel, then the coefficients along x-axis, the coefficient along y-axis, and the coefficient along z-axis, that is the coefficient of I cap, j cap, and k cap, should be in the same proportion. Here we are having no coefficient of I cap and no coefficient of j cap. These two are 0. So here also these two should be 0. This implies p minus 1 should be 0. So p will be equals to 1. So option A is correct. Similarly, minus r or r should be equals to 0. So option B is correct. Now, if these two are 0, then we are having here it minus 2 j cap and it is p plus 1 j cap. These two are along the same directions, j cap and j cap. Magnitude can be different because they are parallel. But here, q cannot be equals to minus 1 because when q will be equals to minus 1, then the coefficient of j cap will be 0, which should not be the case. So option D is correct. Here option C is not correct because q is all the real numbers, but q can be any real number minus 1. Moving to the next question. We are given A, B, C are non-coplanar vectors and lambda is a real number, then the vectors A plus 2B plus 3C, wherein this one vector, the other vector is lambda B plus mu C and 2 lambda minus 1 C are coplanar. So if the three vectors are coplanar, then the determinant value is 0. So for the first one, the coefficients are 1, 2, and 3. For the second one, 0, lambda, and mu. And for the third one, it is 0, 0, and 2 lambda minus 1. And this should be equals to 0. See, since ABC are non-coplanar vectors, and the combination is giving us the coplanar vectors. So on solving this determinant along first row only, so we will be getting first column only, sorry, lambda into 2 lambda minus 1 minus mu into 0 equal to 0. So that will be lambda into 2 lambda minus 1 equals to 0. So on solving, we will get lambda equals to 0 or lambda equals to 1 by 2. So the value can of lambda can be 1 by 2 or the value of lambda can be 0, and mu can belongs to any real number. So our correct options are A, B, and C. Moving to the next question. It is given if the resultant of the three forces F1, F2, and F3 acting on a particle has a magnitude equals to 5 units, then the value of P is. So it is a very simple question. We have to just add the three forces F1 plus F2 plus F3, and we'd be getting, sorry, Pi cap. Here we are having this. So So on adding, we will get P plus 1 I cap plus 4 J cap. It is given that the magnitude of resultant is 5, that is P plus 1 whole square plus 4 square is 25. So on solving, we will get P plus 1 whole square equals to 9. So P plus 1 equals to 3 or P plus 1 is equals to minus 3. So P will be either equals to 2 or P will be either equals to 4. So the correct options will be B and C. Going to the next question. It is given the vector I cap plus xj cap plus 3k cap is rotated through an angle and it is doubled in the magnitude. It now becomes this vector, the value of xr. See, we have rotated it through some angle and we have doubled the magnitude. Let's say this vector is something r vector alpha. So I cap plus x j cap plus 3k cap. Let's say this vector is our beta. So beta is 4i cap plus 4x minus 2 j cap plus 2k cap. Now mod of beta is given to be 2 times the mod of alpha because it is given that the magnitude is doubled. Because when only it will be rotated, then magnitude will remain constant. Now it is given that with rotation we have made its magnitude doubled. So this will be the case. So mod beta square will be equals to 4 times of magnitude of alpha square. So we will be getting 16 plus 4x minus 2 whole square plus 2 square is equals to 4 times of 1 plus x square plus 9. So on solving this, we will get a quadratic equation in x, and from this the two roots will be x will be equals to 2 or x will be equals to minus 2 by 3. So the correct options will be 2 or minus 2 by 3, that were B and C. Now moving to the next question. We are given A and B, the vertices are given. Then which of the following points lie on the bisector of the angle between OA and OB? O being the point of reference. See, if O is being the point of reference, then vector OA and vector OB will represent the two sides of the parallelogram, and this will be the resultant. So let's find vector OA here. So OA will be vector OA, let's say its name A, vector B, position vector of A minus origin, that will be minus 4i cap plus 3k cap. But we have to find that it should be the angle bisector. So angle bisector will be the only case when, okay, I have not seen that it is an angle bisector. So angle bisector will be the case when the two vectors have equal magnitude. So when the two vectors will have equal magnitude, that is, we have to find the unit vector along OA and we have to find the unit vector along OB. So the unit vector along OA will be this upon 5 and the unit vector along OB will be 14i cap plus 2j cap minus 5k cap divided by under the root 14 square plus 2 square plus 5 square. So that will be 15. So we are having the vector A and vector B in here. So A plus B or A minus B. So one diagonal will be A plus B and the other diagonal will be A minus B. So we have to find this lambda times of plus minus. So when we will add these two vectors, let's move to the next slide and see what we are getting in here. So from A plus B, we will be getting the vector R in here and its value will be I cap plus j cap plus 2k cap, and it will be the sum multiple. So let's say which all options satisfies our condition. For I cap plus j cap plus 2k cap, and outside we were having some constant value mu. So the points that will satisfy is 2, 2, 4, 1, 1, 2, or any other multiple of this, that is minus 3, minus 3, 6. So our correct options will be A, C and D. What we have to do here is we have to find the angle bisector and we have to find the points lying on the angle bisector. So first find a unit vector along this and then find a unit vector along this. These two vectors will have the same magnitude, so the resultant will pass from the between in between the two vectors, so that vector will give us the angle bisector. For that, magnitudes of the two vectors should be same. So better to find a unit vector. Going to the next question. In a four-dimensional space where unit vectors along the axis are I cap, j cap and k cap and L cap, and a1, a2, a3, a4 are the four non-zero vectors such that no vector can be expressed as a linear combination of other, and this value is equals to 0, then if they are linearly independent, then for a1 we have to rewrite it as lambda minus 1 vector a1 plus minus of lambda minus 1 plus mu minus 2 a2 plus mu plus lambda plus 1 a3 plus lambda plus delta a4 equals to 0. So if these all are 0 and we are giving it by linear combination and they are all the unit vectors along the four dimensions, so the coefficients must be 0, then only this condition is possible. So that is lambda minus 1 equals to 0, 1 minus lambda plus mu minus 2 equals to 0, and mu plus lambda plus 1 equals to 0, lambda plus delta equals to 0. And on solving all this, we will be getting lambda equals to 1, mu equals to 2 by 3, gamma equals to minus 1 by 3, and delta equals to 1 by 3. Let's see which all options satisfies our conditions. So lambda was equals to 1, mu was equals to 2 by 3, so this is not satisfying our condition. Okay, mu was, and delta was equals to 1 by 3, so mu was 2 by 3 only. Okay, it is given minus 2 by 3, and delta it is 1 by 3. So this is not satisfying. Option A and D are satisfying our conditions. Moving to the next question. Let ABC be a triangle, then the position vector of whose the position vectors are given. The position vectors of whose vertices are this, this, and this. Then the type of triangle ABC. So we are given the vertices, the coordinates of the vertices. So we can find, let's say A is 7j cap plus 10k cap, B is minus I cap plus 6j cap plus 6k cap, C is minus 4I cap plus 9j cap plus 6k cap. So we can find the vector AB, that is position vector of B minus A. We can find BC and similarly vector CA. Okay. So we found out vector AB, vector BC, vector CA. This is simple question. By subtracting the two position vectors, we will get the vector. And we can see here the magnitude of AB and the magnitude of BC are same, and magnitude of CA is 6, and it is even following Pythagoras theorem, so it is a right angled isosceles triangle. But you can otherwise do it, you can also find the dot product. See here, B is the right angle, so A dot B, B dot C, if you will find the dot product of vector AB and BC. So that will be minus 3 into minus 1, that is 3, plus 3 into minus 1, that is minus 3. And here k cap is 0, so that will be 0. So it is 0, dot product is 0. That is the vector containing AB and BC is 90 degree, that is angle B is 90 degree. So it is a right angle triangle. And from the magnitudes, we can see that it is an isosceles triangle. So the correct options are right angle and isosceles. Okay. So that's it for today. Thank you, everybody.